Okay, let's unpack this. Ever feel like your brain's just got, I don't know, a million tabs open and like half are trying to understand something really complicated while the other half are just wondering what snack to grab?
Yeah, I know that feeling.
Me too. And if you're tuning in, you, the learner, probably know exactly that feeling of facing down a mountain of information.
It's interesting, isn't it? Our brains naturally go for the immediate stuff. Tackling something dense, something complex, it can feel less urgent than figuring out dinner.
Totally.
But that's where, a focused exploration really helps.
Exactly. So welcome to the deep dive. This is your shortcut to those aha moments. We take all that information overload and we distill it down, get you the essential insights you actually need.
And today's topic is a big one.
It is. Today we're tackling software architecture and our guide. It's the book Head First Software Architecture by Raju Gandhi, Mark Richards, and Neil Ford.
Yeah, it's a really good one. It offers a practical and pretty accessible way into a field that can seem, pretty abstract sometimes. These authors, they definitely bring a lot of real-world experience.
Right. So our mission on this deep dive is to cut through all that complexity. We're going to nail down what makes software architecture different from just, plain software design.
That's a key distinction.
Yeah. And we'll get a solid grasp on architectural characteristics, those crucial qualities of a system. And maybe most importantly, we'll unlock the wisdom of the two laws of software architecture. They sound formal, but they're more fundamental than you might think.
It's really about building that strong foundation. So understanding the more advanced stuff, the different architectural styles and patterns, it becomes much, much easier later on.
Exactly. And how does this connect to you, the listener? Well, whether you're writing code, maybe leading a team, or just trying to understand the tech buzzing around you, knowing these architectural basics. It gives you a really powerful lens.
Yeah, a lens to evaluate decisions, to understand why systems are built the way they are.
So get ready for some seriously useful takeaways, whether you're like prepping for a meeting, trying to level up your tech knowledge, or maybe just feeding that curiosity.
Yeah.
This deep dive is specifically for you.
Okay, so where should we start? Maybe with that fundamental question. How exactly does software architecture differ from software design?
Because it's not always immediately obvious, is it?
That's a great starting point. And yeah, probably what a lot of you are wondering, the book uses this really helpful analogy. Think about building a house.
Okay.
The software architecture, that's like the blueprints.
Yeah.
The overall structure, where the rooms go, the foundation, all that big picture stuff.
Like the high-level plan.
Exactly. And then software design, well, that's more like the interior design, the specifics within each room, the paint colors, the furniture, the fixtures. Architecture provides the guidelines and constraints. Yeah, and what's key there is that the architecture really dictates the possibilities for the design. I mean, the blueprint determines the size and layout of the rooms, right?
Yeah.
Which then influences, your choices for how you decorate them. You can't put a giant sofa in a tiny room defined by the architecture.
Makes sense. The book also mentions 4 dimensions of software architecture. Doesn't go super deep right away, but it's like, describing anything complex, right? A car, a city, you need to look at it from multiple angles.
Precisely. You need multiple viewpoints to get the full picture. Software architecture is the same.
Got it.
And to really get clear on where architecture sort of ends and design begins, the book looks at it more like a spectrum. It's not really a sharp dividing line.
A spectrum. Okay.
Yeah.
Let's unpack that. How do we decide if something falls more on the architecture side or the design side? The book gives us a few ways to think about it.
Yeah, like strategic versus tactical.
Right. Strategic versus tactical decisions. Back to our house analogy.
Right.
Deciding how many bedrooms or bathrooms.
Yeah.
That's strategic.
Right.
So a long-term decision, big impact.
Definitely.
But choosing the style of faucet in the bathroom, that's tactical.
Yeah.
It's more localized, easier to change maybe.
Yeah, much smaller blast radius if you get it wrong.
Exactly. So in software, like choosing to go with microservices versus a monolith, that's strategic architectural. Designing a specific API endpoint within one of those microservices, more tactical, more design.
And that ties into how hard things are to reverse, doesn't it? Architectural decisions, they tend to be foundational. They're baked in deep, much harder, and usually much more expensive to change later on.
Yeah, good point. Okay, another angle is the level of effort involved.
Right.
Imagine like replatforming an entire application to a different cloud provider. That's huge effort. Clearly architecture.
Massive undertaking.
But tweaking the CSS on a button on a web page, relatively low effort. That feels like design.
Yeah, the effort often reflects the scope, Architectural changes usually touch the fundamental structure, lots of parts of the system. Design changes are often more contained.
Okay, and the last one they mentioned is significant versus less significant trade-offs. This sounds important, and I know we'll dig into trade-offs more later.
It's crucial, absolutely crucial.
So consider this. Deciding whether to build a system for, say, high availability with redundancy across multiple data centers. That involves major trade-offs, right? Cost, complexity. That feels very architectural.
Oh, absolutely. Big trade-offs there.
But choosing, I don't know, a specific shade of blue for a button,
Yeah.
the trade-offs are, well, pretty minor in the grand scheme of things. That's design.
Right. Maybe some user experience feedback, but not fundamental system structure.
So let's try and summarize this first bit. Software architecture is about the big picture, the structure, the main components, how they connect, how they talk to each other.
Yeah, the fundamental organization.
And software design is more about the details within those components, the implementation specifics.
And the more strategic a decision is, the higher the effort involved and the more significant the trade-offs, the more likely it leans towards being an architectural concern.
Okay, got it. That distinction feels much clearer now.
Mm-hmm.
So the book then moves on to architectural characteristics. This sounds like we're moving beyond just the structural blueprint.
Exactly. Think of architectural characteristics as, well, they're often called non-functional requirements, though the book prefers architectural characteristics. They're not about what the software does, that's the business logic, the domain.
Right.
They're about how well it performs certain things and how it's built. These are the qualities, like security, scalability, maintainability, performance, reliability, all those optimally.
The abilities. Okay. So if the software needs to, say, process payments, that's the domain, the what.
Right.
But needing it to process 10,000 payments per minute, that's a characteristic. That's performance, the how well.
Precisely. And the book makes a really good point here. People focused on the business requirements, the domain stuff, they might not always fully grasp how their requests impact these architectural characteristics.
Interesting. Like a seemingly small feature request could actually have huge architectural implications.
Exactly. It might require significant changes to support, say, the performance or scalability needed, which wasn't obvious from just the feature description.
That makes a lot of sense. So how does the book actually define these characteristics then? It gives a few angles.
Yeah, it defines them in a few ways. First, as non-domain design considerations, so aspects beyond the core business functionality.
Okay.
Second, they cover the operational qualities, the structural choices, and other essential attributes of a system, sort of regardless of what the system actually does.
Right.
And third, they act as a kind of filter, a way to help us prioritize and, importantly, avoid overcomplicating things.
Overcomplicating or over-engineering. Yeah, definitely something to watch out for. Trying to build in features or capacities you don't actually need yet.
Absolutely. I mean, there are a huge number of potential architectural characteristics, and new ones are always popping up, especially with things like cloud computing, AI, etc.
Right.
If you try to optimize for every single possible illity, you'll end up with a system that's incredibly complex, probably expensive, and really hard to manage or change.
So prioritization is key.
Totally. Filtering based on what's truly critical or important for this specific application's success is essential.
Now, what about those implicit characteristics the book mentions? Things like having a well-organized code base or making it easy to update. Nobody explicitly asks for maintainable code, right?
Yeah.
But it's vital.
They are absolutely crucial for the long-term health and sustainability of the software, while a client or product owner might not put high maintainability on a feature list.
Yeah, probably not.
A good architect understands that things like maintainability, testability, deployability, these are fundamental. They enable future development, they make fixing bugs easier and faster, they reduce risk. These implicit characteristics often drive key architectural decisions, even if they aren't explicitly requested by the business.
Okay. So the book then talks about the International Zoo of Facilities. It's a fun phrase.
It is, isn't it? It's just a memorable way to highlight the sheer number of these architectural characteristics, so many of which end with facility.
Right.
But the key takeaway isn't the fun name. It's that there isn't and probably never will be a single, definitive, universally agreed upon list of all possible characteristics. The field just moves too fast.
Okay, so no official zoo catalog we can just look up, but the book does give us some categories to help organize them, right?
Yes, absolutely. It groups them quite usefully. For example, there's process characteristics, which include things like agility and modularity, basically, how easily the software can be developed and changed over time.
Okay, process.
Yeah.
What else?
Then there's structural characteristics like maintainability, testability, deployability, things related to the system's internal makeup and how easy it is to work with.
Makes sense.
Then you have operational characteristics. These cover how the system behaves when it's actually running. Think performance, scalability, availability, reliability, fault tolerance, elasticity, all that runtime stuff.
Right, the things users often notice directly.
Often, yes. Then there are cross-cutting characteristics. These tend to affect many different parts of the system. Security is a big one here, also privacy, authentication, authorization, usability.
Okay, that covers a lot.
And finally, there's sort of a broader category for other important all abilities that might not fit neatly elsewhere, like robustness, accessibility, configurability, customizability, recoverability, auditability. The list goes on.
Wow, okay. It really is a zoo. It's also interesting how many of them seem linked. Like, the book mentions reliability being a composite characteristic.
Exactly right. Reliability isn't usually a single, isolated quality you just add. It's often the result of other characteristics working together effectively. For instance, high reliability might come from a combination of good fault tolerance, high availability, maybe robust error handling, and recoverability.
Ah, I see.
And to make these characteristics meaningful, the book really emphasizes the importance of having objective ways to measure them. It's not enough to just say, we need good performance.
Right, what does good mean?
Exactly. You need to define it with concrete metrics, like average API response time must be under 200 milliseconds under a load of 500 concurrent users. Something specific you can actually test and verify.
Okay, that makes sense. Measurement is key.
Yeah.
So where do these characteristics actually come from? How do we decide which ones matter for a particular project?
Well, they primarily stem from two main sources, according to the book. First, the problem domain itself, the actual requirements of the software.
So back to the what it does.
Yeah. If the system needs to handle, say, a huge volume of concurrent users or process massive amounts of data, that directly translates into requirements for characteristics like scalability, performance, maybe elasticity.
Okay, domain requirements. What's the second source?
The second source is what the book calls the environmental context. This includes the organization's broader goals, its priorities, maybe its technical constraints, or even its culture.
Ah, like the company itself.
Exactly. For example, a startup that needs to iterate really fast and pivot quickly will likely prioritize characteristics like agility and deployability very highly.
Makes sense. Get features out fast.
Right. Whereas maybe a large, highly regulated financial institution will put enormous emphasis on security, auditability, and perhaps reliability.
Okay. So it's this balancing act then between what the software needs to do with the domain and how it needs to be. The characteristics driven by both domain and environment.
Precisely. You can't really design a functional system without considering its non-functional qualities, and vice versa. They're intertwined.
Now, the book mentions this intriguing, magical number 7 guideline. What's the thinking behind that? 7 characteristics.
Yeah, it's a really practical tip, mostly for focusing discussions, especially with stakeholders who might not be deep in the technical weeds.
Okay.
Cognitive load research suggests that our short-term memory can comfortably handle around, 7 pieces of information at once, give or take. So the book suggests that when you're initially defining and discussing architectural characteristics, try to focus on around 7 key ones.
To avoid overwhelming people.
Exactly. It helps keep the conversation focused on what's most important. And within those 7, it's often helpful to identify maybe the top 3 driving characteristics.
Driving characteristics.
Yeah, the ones that will most significantly influence the actual architectural design decisions you make. And alongside those explicit ones, you always need to keep in mind those implicit characteristics we talked about, maintainability, testability, etc., because they're vital even if they're not in the top 7 list discussed with stakeholders.
Okay, that's a really useful heuristic. Keep the conversation manageable. Identify the core drivers, but don't forget the implicit essentials. The book gives an example, right? Using a fictional app called Laughter.
Yes, the laughter example is good. It shows how to translate a business need into architectural characteristics.
How did that work?
Well, the example highlighted a business requirement stating that laughter is constantly changing to meet new marketplace demands. A statement like that, which sounds purely business-focused.
Yeah, sounds like something marketing would say.
Right. But it directly implies the need for specific architectural characteristics. If the system needs to adapt quickly, what does that mean architecturally?
It needs to be easy to change,
Hmm.
flexible.
Exactly. It translates directly into needing characteristics like agility, modularity, breaking it into changeable parts, and extensibility, making it easy to add new features without breaking old ones.
Ah, okay. So you derive the necessary scalabilities from the business pressures.
Pres-
Okay, this is great. We've got a much better handle on what software architecture is versus design and why these architectural characteristics are so critical. Now we get to what sound like the core principles, the two laws of software architecture.
Yes, these are fundamental.
The first one sounds pretty definitive. Everything in software architecture is a trade-off. That feels like a universal truth, not just in software.
It really is absolutely fundamental in this context. This first law basically states that every single decision you make when designing software architecture will inevitably have both upsides and downsides. Pros and cons.
No silver bullets.
No silver bullets. There's no perfect, universally ideal solution that satisfies every single requirement and every desired architectural characteristic flawlessly with no drawbacks. The book even says if a particular architectural choice seems like it's all positive, all upside with absolutely no downsides,
Yeah.
you simply haven't looked hard enough. You haven't dug deep enough into the implications. There's always a trade-off somewhere.
Okay, that's a strong statement.
Mm-hmm.
Can you give us a more concrete example of this trade-off in action?
Sure. The book uses a good one, choosing between using message queues versus message topics for asynchronous communication between services.
Okay, queues versus topics.
Right. If you use queues, typically one sending service talks to one specific receiving service via that queue. This gives you tight coupling, which can sometimes be good, maybe easier monitoring of that specific consumer, potentially simpler guarantees about message delivery to that one consumer.
Okay, tighter coupling, maybe simpler direct monitoring.
But the trade-off is flexibility. What if, later on, a new second service also needs to receive those same messages? With a queue, you might have to reconfigure the original sender, or duplicate the message stream, or set up complex routing. It adds complexity because of that initial tight coupling.
Right, less extensible.
Exactly. Now, if you use topics, the sending service just publishes a message to the topic, and any number of services can subscribe independently to receive a copy of that message. This gives you much looser coupling, much greater flexibility and extensibility. Easy to add new listeners.
Sounds better. So what's the trade-off?
Well, the trade-offs might be in areas like guaranteed delivery, sometimes harder to ensure every subscriber definitely got it and processed it exactly once. Or perhaps monitoring becomes more complex because you have many independent subscribers instead of one known consumer. Maybe message ordering guarantees change.
Ah, okay. So the trade-off is like coupling and monitoring simplicity, queues, versus flexibility and extensibility topics with different reliability or management challenges.
Exactly. Neither is universally better. The right choice depends entirely on your specific needs, priorities, and what trade-offs you're willing to accept for this particular situation.
So the crucial question an architect always needs to be asking for any approach is, okay, what are the trade-offs here?
Precisely. Understanding those trade-offs, the pros and the cons, is what allows you to make informed decisions. Decisions that actually align with your project's specific goals, constraints, and the architectural characteristics you've prioritized.
Okay. And it helps kind of formalize this process to make sure these trade-offs are actually considered and recorded. The book introduces architectural decision records, or ADRs.
Yes, ADRs. Think of them as a way to systematically capture the why behind your key architectural choices. Not just what you decided, but why you decided it, including the trade-offs you considered.
ADRs. These sound like they could be incredibly valuable, like creating a kind of institutional memory for a project's architecture so people joining later understand the history.
That's exactly one of the main benefits. ADRs are essentially short, simple documents that record significant architectural decisions. Each ADR typically captures the context surrounding the decision, the actual decision made, and most importantly, the reasoning behind it, the alternatives considered, the trade-offs weighed. They serve as a historical log.
Okay. The book outlines, I think, 7 key sections for a good ADR. What are those?
That's right, 7 sections. They are title, status, context, decision, consequences, governance, and notes.
Okay. Title and status seem straightforward.
Yeah, the title should be clear, concise, and maybe descriptive of the decision. Often, they use a numbered prefix like 0001, use message queues for order processing, for easy tracking and sequencing. The status indicates where the decision is in its life cycle. Is it still just proposed? Is it under request for comment, RFC? Has it been accepted? Or maybe it's been superseded by a later decision.
That superseded status sounds important. It shows how the thinking evolved, right? You don't just delete old decisions.
Exactly. You mark it as superseded and ideally link to the new ADR that replaced it. This preserves the history. Editing old ADRs directly can mess up the chronology and understanding.
Okay, then context.
Context explains the background. What was the problem or force driving this decision? What were the goals? What constraints were we operating under? It sets the stage.
Got it. And then the crucial decision section.
Yes. This clearly states what choice was made. But crucially, it also includes the justification, the primary reasons why this option was chosen over others. This is where you start capturing the why.
Okay, the why begins there, and then we have the consequences section. This sounds like where the trade-offs really get documented.
Absolutely. This section is critical. It details the anticipated outcomes of the decision, both positive and negative. What are the benefits we expect? What are the potential drawbacks, risks, or limitations we're accepting?
So really spelling out the trade-offs.
Yes. It should consider the impact on different areas. The implementation teams, the end users or customers, maybe cross-cutting concerns like security or performance, and definitely impacts on schedule, budget, or operational complexity. The book stresses that even seemingly simple architectural decisions almost always have consequences you should think through.
Okay, that leaves the last two sections, governance and notes.
Right. Governance is about any specific policies, standards, or guidelines related to this decision, like who needs to approve changes related to this? Are there specific compliance rules that apply? Things like that.
Okay.
And the notes section is just a catch-all for any other relevant information, maybe links to related documents, diagrams, research papers, open questions that still need resolving, future considerations, etc.
Okay, ADRs sound like a really structured way to handle law number one. Everything's a trade-off. Now, what about the second law? It's why is more important than how?
Yes, the second law. This really builds on the first law and the value of ADRs.
How so?
It emphasizes that understanding the rationale, the underlying reasons, the context, the trade-offs considered behind an architectural decision is ultimately far more valuable in the long run than simply knowing what the decision was.
So knowing why we chose microservices is more important than just knowing that we chose microservices.
Exactly. Because the why provides crucial understanding. It helps future teams when they need to modify or extend the system. It helps onboard new team members so they understand the design philosophy. It even helps you intelligently revisit past decisions if the context or constraints change. Without the why, you're just looking at the how, the implementation, without understanding the forces that shaped it.
And this is where ADRs really shine, right? Because their whole purpose is to capture and communicate that why.
Precisely. A good set of ADRs documents the thinking process, the alternatives explored, the trade-offs weighed, and the specific context that led to each significant architectural choice. It creates that invaluable historical record, that project memory store that makes the why accessible to everyone who needs it.
Okay, fantastic. So let's try to wrap up our deep dive for today. We've really clarified that difference between software architecture, the structure, and design the details.
Yeah, looking at it through strategy, effort, and trade-offs.
We explored the vital role of architectural characteristics, those utilities, in defining a system's essential qualities beyond just its features.
And the importance of prioritizing them and making them measurable.
And we uncovered the fundamental two laws of software architecture. First, everything is a trade-off, always.
No free lunch.
Right. And second, understanding the why behind a decision is more important than just knowing the how.
Because the rationale guides future evolution.
And we also highlighted a practical tool, architectural decision records, ADRs, for actually capturing that crucial why and the trade-offs involved.
And bringing this all back to you, the listener, understanding these foundational principles, it really gives you a powerful framework. You can use it to analyze pretty much any software system you encounter or work on.
How so?
Well, you can now start to think more critically about it. What are the likely architectural characteristics driving its design? What trade-offs were probably made when it was built? And how well is the underlying rationale, the why, understood and communicated?
That's right. It gives you a new way to look at things. So here's a final thought for you to maybe chew on. Think about a recent technical decision you've encountered. Could be in a project you're working on, something you read about, anything.
Yeah.
Try to analyze it through this lens of trade-offs. What were the potential pros and cons of the approach that was chosen? What were the alternatives maybe? And thinking about that second law, was the why, the justification behind that decision clearly articulated? Was it well understood by everyone involved? Or was it kind of just accepted?
That's a great exercise. It really forces you to apply these ideas. And remember, this deep dive, it's giving you a solid foundation and some core architectural concepts. But as you can probably guess, this is really just scratching the surface.
Right.
There's a vast and constantly evolving landscape out there of different architectural styles, patterns, technologies, and more complex considerations.
Absolutely. But hopefully this gives you the grounding to explore that further. And we'll definitely be here to guide you through more of that landscape in future deep dives.
Looking forward to it.
So stay tuned for more in-depth explorations into the fascinating and crucial world of software architecture.